You know that feeling when you're playing a game or even just swiping through your phone and you just have to stop for a second and admire how good it looks? Well, that visual magic, it's not an accident. It's actually the work of these tiny, super fast programs. And today, we're going to pull back the curtain and see exactly how they build the amazing worlds on our screens.
I mean, really think about it. We start with what's basically a digital skeleton, right? Just a bunch of points and lines in 3D space. So how on earth does that become this vibrant, living, breathing world? How do you get from a simple blueprint to a visual masterpiece? Well, the answer comes down to two words: programmable shaders. Think of them like these two hidden artists just working away at incredible speeds inside your computer's graphics card. The GPU. They are the ones painting every single thing that you see. So let's actually trace that journey, right from the raw mathematics all the way to the pure magic that ends up on your screen. We're about to see how these little programs can take abstract data and just spin it into the visuals that pretty much define our digital lives now. So first up, what even is a shader? To put it simply, it's a tiny, lightning-fast program. It doesn't run on your computer's main brain, it runs on the GPU, which is specifically built to do thousands of these little visual calculations all at once. Their one job, their only job, is to create what you see. Okay, to really get a handle on this, you've got to meet our two main artists. I love this analogy. Think of the Vertex shader as the architect. It's the one who lays out the foundation and the structure of everything. And then you have the Fragment shader, who's like the master painter, coming in afterwards to add all the color, the light, the texture, all the beautiful details. And, it's this amazing division of labor between the two that makes all of this possible. Each one has a very specific, super specialized role in this whole creative process. So here's how it all breaks down. The Vertex shader is all about the where. It handles the 3D points, the vertices, and figures out the object's shape and where it goes. Then the Fragment shader, and you'll also hear this called a pixel shader, same thing. It handles the what, as in what does this thing actually look like, down to every single glorious pixel. So the Vertex shader is basically a master of geometry. Its job is to take all those mathematical points that make up a 3D model and ask, okay, where is this thing in the virtual world? And based on where our camera is, where exactly should I draw it on your flat 2D monitor? It's all about position and perspective. Right, so once the shape is locked in, the Fragment shader gets to work. And this is nuts. For every single pixel that an object covers on your screen, this shader runs a calculation. It's asking, okay, for this pixel, is it in a shadow? How is the light bouncing off of it? Which part of the texture file am I supposed to paint right here? This is where all the realism comes from. So how do these two, the architect and the painter, actually work together? Well, they work on what's basically a crazy efficient, super high-speed assembly line inside your GPU. We call it the graphics pipeline. Each stage has one job to do, and this entire process happens millions of times a second. It's unbelievable. And that sequence, that order of operations, is everything. It has to be perfect. The GPU is just built from the ground up to push data through this pipeline, transforming it step by step from some abstract 3D idea into that final, beautiful 2D picture that you see. And here are the core steps of that assembly line. First, vertex shading. Our architect builds the 3D shape in space. Then, step 2, this really clever part called rasterization. This is where the GPU looks at that 3D shape and basically lays a 2D grid over it, figuring out exactly which pixels it's going to cover. It's like creating a perfect paint-by-numbers canvas. And then finally, step 3, fragment shading. Our master painter comes in and fills in every single one of those squares with the final, perfect color. Okay, so this stuff is really cool from a techie point of view, I get it. But why does it actually matter to you? How does this technology really change the digital world you see and use every single day? While the secret sauce here is the absolutely mind-boggling scale, we're not talking about a few calculations. We're talking millions and millions of calculations for light, color, and position happening all at the same time every single second. That massive parallel processing is what lets us have the smooth 60 frames per second graphics we just expect now. And once you know what to look for, you see this power literally everywhere. In games, shaders make the water ripple, they make skin look soft, they make explosions, well, explode. On your phone, they're responsible for that smooth blur effect when a notification pops up. In VR, they are absolutely critical, rendering everything super fast so you don't get motion sick.
They are the engine of almost every visual you see on a screen. But creating magic like this isn't easy. It's not free. Just like any powerful technology, it comes with its own set of challenges and trade-offs that developers are constantly fighting with. Yeah, for every incredible visual effect, there's always a cost. If you make a shader too complicated, your frame rate can drop and you get lag. Brand new shader techniques, well, they probably won't run on older graphics cards. And let me tell you, writing and debugging this code is legendarily difficult. Plus, all this hard work takes a lot of electricity and creates a whole lot of heat. It's a constant balancing act.
So at the end of the day, when you boil it all down, it comes back to this really elegant partnership. You've got the architect and the painter, the Vertex and Fragment shaders, working together in perfect sync on that high-speed assembly line. It's their teamwork that turns cold, hard math into the living, breathing worlds that fill our screens.
And that kind of leaves us with a final thought, right? Because this tech is just getting more and more powerful every year. So what's the one thing you're most excited to see become perfectly, indistinguishably real on a screen? Is it going to be human faces that finally cross that uncanny valley? Or maybe dynamic weather systems you can almost feel? The unseen artists inside our computers are ready to paint it. And now you know exactly how they do it.